Well, I'm standing between you and lunch, but if you find my subject of my talk as riveting as I do, that shouldn't really be a problem. So it's really great to see so many of you here. You know, Fortanix was founded more than 7 years ago on the principles of confidential computing, but the term confidential computing didn't really exist yet. It's really great to see this field grow to such a big audience today here, and it makes me very, very hopeful for the future. I want to talk about some ideas of like how we should be using confidential computing. What are the best ways to use this technology to actually secure your data, which is what we're trying to do after all. When you think about enterprise security, the way it's been implemented in the past, along with identity management and endpoint security, network perimeter security has been one of the pillars of enterprise security, really. But really now we've started to see that foundation crumble. When you don't read in the media about a network breach, no one really cares about that, right? What people care about is data breaches, and that's also what you then read about. So the thing is, if you only implement those three security pillars that I mentioned before, yeah, it's not sufficient really, right? You see, with perimeter-based approach, you know, you have this walled garden. Once you're inside, you have access to everything, right? And security practitioners know this, right? So we really need to move the bar to go to data security. So let me see how we, let's dive into that a bit more from a practical perspective. Like what does it actually look like, you know, when we're talking about securing data? Here's an example. I have a typical virtual machine workload, right? We have an operating system. Maybe we're using some kind of orchestration layer. I have a remote management tool like SSH, application server, a database, and these don't all necessarily have to run in the same VM, but for the sake of exposition, it doesn't really matter too much. And this is basically how all software today runs, right? Like, and it doesn't matter if you're talking about a web application or a larger SaaS or enterprise internal applications. You can generally just separate it in some kind of application logic and some state that's being managed. If you then look at what is underneath these pieces in terms of like data and data access, you come to the conclusion pretty quickly that there's really a lot there, right? So starting with the application, probably there is some API keys to talk to other services. There's a TLS private key to, as a internet identity. There's database credentials to actually interact with the database to have access to the right data. The database itself, of course, stores a whole lot of user data, which should really all be considered sensitive, right? Like, it doesn't really make sense to subdivide that into more categories. Just think about all of it as sensitive. And then, surprisingly, there's through this remote management tool, there's a way for an administrator to log in and have access to all of this. That's not really why. Like, that's completely unnecessary, right? So really, what you've done, you know, if you move away from like network perimeter-based security and you look at a VM, right? Like, you're just moving the line. You still have this walled garden. It's just a lot smaller, but it's still there. You can, once you're inside a VM, you know, either through leaked credentials or a remote code execution vulnerability or some other kind of attack, maybe a faulty hypervisor. Once you're in, you have access to everything again. So it's really just moving the security barrier and not really fundamentally changing the security of the data inside your systems. So there was an article like just last month that really showed that, yes, there's this out-of-band management capability that is being misused to access data in VMs this way. And so this is not just a hypothetical, this is actually happening today. So, okay, we are here for confidential computing, right? We're trying to secure the data. So how do we go about that, right? Well, so you just go to your favorite cloud service provider, you click the launch a new VM button, you type in a name, and then, of course, you just check the checkbox that says encrypted VM, and then you're done, right? Wrong. If you just move your existing workloads, VM-based workloads, to confidential computing, that's not sufficient, right? As I've just shown, that's just a barrier around the VM itself. But once you're inside, you still have access to everything, right? What you really need to do is, rethink your architecture, your security, to protect data in use specifically, right? If you have an encrypted VM and you are still running SSH in there, you can just get in, and your administrator still has access to everything inside there. So how can we, what are practical steps that we actually can take to have this data in use protection, right? And not just tick a checkbox. So, I showed these different pieces of information that exist, these different concerns within the VM. Let's take a look at each of them and see what we actually can do to make it better. So when it comes to any persistent state, like the database data I talked about, or TLS private key, this is where you should be using trusted execution environment-based secure storage, like sealing. What this does is ensures that this data is only accessible by the right application, right? If it's encrypted, stored out when it's stored outside, and after that, right, there's just no way to access it except by the specific application that this data is intended to be used by. When it comes to API keys or other credentials, these should be replaced by remote attestation-based identities. Remote attestation, of course, gives you the ability to prove what kind of software is running on the other side. So this is very good in machine-to-machine communication to give the relying party the opportunity to not just check a password or some other kind of credential, but to truly know that the client or database client, for example, right, it actually is authorized to access whatever it is that it is requesting access to. Right? It can actually verify the application, the specific software version that it's running in a legitimate trusted execution environment. Right? So this gives you much better access control, much better policy control over how data is shared between different applications. And then when it comes to the last point, administrative access, this is where we really need to rethink how things are being built. We need to redesign the concept of administrative access with privilege separation in mind. It doesn't really make sense that a person who is logging into a system to do software updates also has access to the TLS private key. It doesn't make sense that someone who's trying to optimize database queries to make them more performant also has access to all the data that is inside the database. Here's maybe something that we can learn from like DevOps principles like immutable artifacts. But if we do that, right, if we use immutable artifacts, we don't need an administrator to go in and do software updates. Right? You just replace the whole software as a whole. So you've basically eliminated this whole class of administrative access that was previously required. Good. So I hope this gives you some idea of how to practically actually make forward progress in terms of securing data in use. This, of course, all we do at Fortanix. My colleague Richard is giving a talk later today on a confidential data search, which we announced just this week. So in track 2, you can find him there. And on that note, I really would like to end and say that protecting data in use is more than just a checkbox, and we need to all work together to make it easy to make that transition. Thank you.